Good morning, everyone. Welcome to today's webinar on QIF 101, Understanding QIF Basics by Curtis Brown. Before we get started, I'd like to go over a few housekeeping items. Curtis, can you? Thank you. You'll have the opportunity to submit questions to us today. We're going to keep you in muted mode for the presentation. You may send the questions by your webinar form, and you can see on this picture here that we have, there's a section that asks questions. We'll be monitoring that, and at the end we'll be doing Q&A at the end of today's presentation. At the end, you'll receive an email link for today's webinar presentation. And today's speaker is Curtis Brown, who will be doing the QIF 101, Understanding QIF Basics. He's a lead mechanical engineer at Honeywell, and he is also the head of our group, the Digital Metrology Standards Consortium, president of the DMSC. And with that, Curtis, please take it away.
All right, thank you, Ray, and thank you everybody for participating in the first of several QIF tutorials. As Ray may have mentioned, or you may have heard, we had planned on performing these tutorials at the FY20 NIST MBE Summit. And so because of the cancellation of that, we decided to create these webinars. So welcome everybody, and I get the privilege of talking about attempting some basics and some understandings of that. So first, I'd like to talk about a little bit about who we are, what's the Digital Metrology Standards Consortium. Then we'll review a manufacturing quality activity workflow so that we can kind of better understand where the QIF fits. Then we'll talk about some high-level understanding about the QIF and some workflows, and then how the QIF might help us transform our digital transformation into model-based enterprise. So first of all, what is the DMSC, or Digital Metrology Standards Consortium? Basically, it is a nonprofit organization. It's cooperative or corporate sponsor. It's cooperative. The concept of it was conceived back in 1983. It became a legal entity in 2005, and at that time it was called the Dimensional Metrology Standards Consortium. And today we are doing business as the Digital Metrology Standards Consortium. Part of our mission statement includes that we want to help identify, promote, and encourage and develop interoperability standards that will help the manufacturing metrology community, and specifically in the area of digital, obviously. We believe that these standards will help impact model-based quality enterprise. Also, the consortium consists of a group of professionals. They include metrologists, they include software developers, some innovators, users, professors, and in combination, we have over 500 years of experience contributing to the QIF, in fact. The DMSC is also developers and maintainers of the Dimensional Measuring Interface Standard. We call it DMS. It's a exchange for coordinate measurement machine part programs. And we're also actively, and that's why you're participating today, maintainers and developers of the new Quality Information Framework standard. The DMSC is an ANSI accredited standards making organization. Therefore, these specifications that we work on, and they have to be worked on in an open manner so anybody can participate. And then those get submitted to ANSI, and then they have a procedure of accepting those. We also are a liaison member within the ISO community. Some may know of the TC 184 SC4 group. They are the same, SC4 is the same group that maintains and monitors the STEP standard that many of you are familiar with. And they are in the process, and I will give you an update on harvesting this ANSI standard as an ISO standard. So some of the objectives of the DMSC is we want to reduce the cost of quality. And we believe we can do that by developing digital interoperability standards that you can trust. And the intent of all these standards is to help impact digital metrology within your manufacturing, but specifically as we start going into becoming model-based enterprise industries. The objectives is to enable freedom, the freedom to choose best-in-class solutions or best-in-value solutions. So interoperability standards allows you that type of freedom. So DMSC's been around. We've been involved with quality standards for a good while. And this is an interesting slide that kind of tells you our pedigree, where we started with DMS 1.0 in 1983. Our first ANSI standard was in 1990 with DMS 2.1. Then at DMS 4.0, we felt like it should be an ISO standard. So in 2001, the ANSI DMS standard 4.0 became an ISO standard. Then you can see that we've provided updates to the DMS standard, and then notice in 2013, the first QIF 1.0 became accepted as an ANSI standard. Some further information, QIF 2.1 was a place where we introduced some persistent IDs, and therefore a need to update the DMS standard for us to add this QIF persistence was also incorporated. So 2016 had a quick modification to the DMS standard to allow QIF persistence. And then the current QIF standard is version 3. It is the ANSI standard officially at 2018. At the end of 2018, we submitted it to the ISO community, and it is being harvested, which basically means takes an existing national standard and converted into an ISO standard, primarily with the cover sheet and copyright. And so 2019, that was accepted, and surely in 2020, all the administrative information needed, QIF should be an ISO standard. As shown below in the bottom, the names for some of our standards in the ISO community, the DMS standard is called ISO 22093. The QIF standard will be called ISO 23952. So I'd like to walk through an example of measuring for manufacturing verification and or product acceptance for using inspection to accept product. And we all will start off with some type of product design or design of the product. And out of that is some product definition with PMI. PMI stands for all the tolerance, information, notes, information necessary for design and manufacturing information. So PMI stands for product and manufacturing information. If you look at your 2D static drawings, that's all the tolerance information, all the annotations. On a model-based definition, that PMI will be 3D annotations that may be associated with your faces of your part and would be the specifications and other notes that you might have, such as surface finish, welding, things like that. Next, in the quality metrology enterprise, you would take that design and based on your quality requirements and manufacturing process, determine your inspection requirements. And basically, this is your measurement scope, a list of what I need to measure. And some people will call this a bill of characteristics because product characteristics are the items or are the individual watts that you need to measure for your particular measurement scope. Then the quality engineer will define the inspection plan or inspection process. So with the list of what he or she needs to inspect, he'll identify the methods or how he's going to perform that particular product characteristic watt, such as use a radius gauge, visual inspection, use a coordinate measurement machine, whatever method you might choose based on your availability of metrology resources and things like that. Then you would actually perform the inspection process, whether that's with a CNC coordinate measurement machine or perform other measurement using other measurement devices. But regardless, you're going to get evaluation results, and those results will be analyzed. You'll create reports of those data, and hopefully that information gets fed back into the overall life cycle. So that's kind of the overall activity, and information gets flows between each one of these boxes. And so these arrows between these boxes. So this gives us opportunities where data gets exchanged, opportunities for the QIF. So a quick slide on what is the QIF. It is currently called ANSI DMSC QIF version 3.0 2018. The name of it is actually an integrated model for manufacturing quality information. Within it, it's kind of divided into four major areas, or really three. It helps define and constrain the measurement and exchange of data. There's a large section dealing with model-based definition, and we'll talk about that, but it is feature-based. It introduces features for metrology or measurement or tolerancing. It also contains semantic PMI or characteristics, as I described earlier. Then there's a major section on quality planning, a list of what. You might want to call it a Q bomb, a quality bomb, but you may be aware of it being called a bill of characteristics. Again, your measurement scope, and then you can extend that plan to a list of hows, attaching methods, and that's where you actually really have an inspection plan. Then I mentioned before, we did extend the DMSC standard so that we could pass through some key persistent IDs. And then with that, we would have measurement results connected to the previous plan and even to the model-based definition. And so we will have measurement results for piece parts, and then we can group those together statistically. One of the key things that is really a key contributor to the quality enterprise is this new concept of adding enterprise connectivity. And the QIF introduced this through what we call a QPlds, or a Quality Persistent ID. And it's nothing different than what you might be familiar with a universally unique ID. And here shows an example of what one of those looks like. And so with that understanding, this helps us identify where the QIF fits back into our QIF activity workflow. And you see where QIF 1.0 fit in, and now with 2 and version 2.1 and with version 3.0, we have identified interoperability components for fitting in between all these major activities. So this kind of shows you the landscape of where the QIF capabilities or applications fit. So you see QIF MBD between design, product, and determine measurement requirements. You see QIF plans between measurement requirements to measurement resources. You see QIF resources and rules contributing to defining your measurement process. Then you see QIF plans again containing the hows. DMSC includes a QIF persistent ID. Then measurement results have QIF results format. and then you can group these results and reporting them in statistics. And then as we maintain that persistent ID, we can influence manufacturing or design. So this is the overall activity workflow and how the QIF could fit into that enterprise. So a couple more high-level descriptors of what the QIF is. It is structured data. It's a schema. We might want to call it, it's characteristic-centric. It's feature-based ontology of manufacturing quality metadata. Ontology is a heavy word, but ontologies basically means it's a formal way that we've named and defined all the data types, attach attributes and properties to them, and then identify how they're interrelated with each other. And this is fundamental for a particular domain of which the QIF fits. Also, the QIF uses a modern approach. It actually uses XML technology, and that gives us the advantages that many understand XML. It has its own simplicity of incorporation. There's lots of tools available for people to use that. There is built-in code validation within this technology, so that gives us a lot of advantages for free. A third major element of the QIF is it is semantically linked to the model-based definition. That allows us full data traceability back to your 3D model or to your CAD model. So that gives us some nice advantages there. So we have connected data, not only amongst the QIF, amongst the quality information needs, but with our product definition. And then the fourth area is standardization, standard artifacts. The QIF consists of a schema artifact that is standardized and the human readable English document that describes that schema and how you implement it. And so both of those together is the QIF standard. And as I mentioned before, it is a ANSI interoperability standard. And as I mentioned before, it is in the latter stages of becoming a ISO QIF standard 23952. So one extra slide on why QPlds, or the persistent UUID within QIF, is so important, and description of what it is. We fondly call it a QPlds, but really it is just a universal unique ID. It follows an ISO standard. I mentioned before, it has that format that typically it kind of looks like this is the kind of the general flavor of that. You may be familiar with how Microsoft has adopted the UIDs as a GUID, GUID. Interesting, the chances of getting two that are identical is 10 to the 38th power. The primary reason why people would use UUIDs or QPlds is to allow for information to be combined later without resolving other identifier conflicts. So it's an easier way to combine information. Luckily, many software development libraries can automatically generate a random UUID for you. Within the QIF, we have strategically placed QPlds on different entities within the QIF. One of the main ones that has significant connectivity and traceability is through this product characteristic item. So again, this is a very important mechanism for life cycle connectivity within not only the quality metrology enterprise, but within the entire model-based enterprise. So a couple other things that we want to talk about is for the QIF is fundamentally, there's this key constructs that the QIF supports, and those are in the area of features and characteristics. We know that model geometry, we can group geometry together and give it more a general name or a feature. QIF features are different than design features that you might see in a CAD application tool. Sometimes you may refer these features as metrology features, measurement features, or tolerance features. Typically, they could be just planar features, cylindricals, that could be holes or bosses, and then the concept of opposite parallel planes would introduce, like a slot or a boss type feature. Then features are referenced by characteristics, and we fondly call them product characteristics. You may also know them as inspection requirements. Those are typical geometric tolerances, dimensional tolerances, specs, or notes. Those are things that the quality engineer or your quality function needs to verify. And then, of course, there's connectivities to them with datums. So the QIF application areas, there's actually 7. They are wrapped around the QIF library. The QIF library is reusable entities that can be reused across all applications. 2 examples of a QIF library is a features library and a characteristic library. One of the first applications is called QIF MBD, or model-based definition. It provides us this opportunity to represent your MBD in a QIF XML format that contains the shape, those features, the PMI/characteristics. And we consider, since quality lives and dies by the PMI, we believe that the QIF MBD has the strongest semantics of PMI as a standard. Another application, as we mentioned before and talked about, is the QIF plans, again, that contains your measurement scope, your bill of characteristics. As you augment it with how or methods, that creates an inspection plan. Then as we think about automating, we knew that we need to represent our measurement resources. So there is a format for people to capture their measurement resource information, whether that might be coordinate measurement machines, probes, calibers, gauges. We need a structured data so that we could read this information for making decisions, either by the human or by automation. Another area is a rule templates for creating measurement rule instances. So an example format is, maybe you want to say, if I have a surface tolerance value of this less than X, then use a CMM method with at least Y number of points. So this template helps you define some rules if you choose to do that. Then again, the DMSC standard is not actually part of the QIF, but it has been extended to be harmonized with data traceability with those QPlds, as I mentioned earlier. And then a key component of the QIF is a standard formatted view of measurement results, and then grouping those results into statistical areas as well. So those are the 7 primary application areas for the QIF. You don't have to use all of those. You can use some, but there are certain workflows that you may use one or many of those. So if you open up the QIF, you'll see that there is one top-level QIF document. And then as you add additional QIF content, you add that to the QIF digital thread. So you may have QIF MBD, you may have QIF plans that you add and extend, resources you could pull into your QIF document. You could have some rules that you could pull into your QIF document. Then that could be exported out through the QIF execution with DMSC 5.3 or other execution software. and then those measurement results can be retrieved and put back into the QIF document, reconnected with your plans and your features, and then statistics could be happening as well. So this is kind of a good little graphic that shows you that you can use one or many of these QIF applications as part of your QIF document. Next, wanted to share with you a workflow example. And the workflow example starts off with a QIF MVD. And based on that, somebody will look at that, pull out all the PMI that needs to be inspected, or your measurement scope. So now you have a QIF plans with your bill of characteristics. And then you might have rules defined and QIF resources, and then now you create your QIF plans with a measurement plan or inspection plan. Then you could generate DMS inspection programs and pass that on, and those top level measurement tasks will have their own QPlds, and you can have that information persist. Then you will get measurement results. First, you'll get maybe point clouds of information for measuring your features, and then you evaluate those against the GD&T or your tolerances or your other specs. And then you'll have a group of QIF results for each part instance, and then you can group that information and perform analyze results with QIF statistics. So that's one good workflow example. All that data could be generated and could be passed on to your source model or your authorities model as well. So full traceability throughout. So what is the business value for QIF? There's two perspectives that we're going to talk about. One is from a manufacturing perspective, and another is from your metrology vendor perspective. We believe it will reduce cost, provides you a common interface for information. Again, it gives the manufacturer freedom of choice to select best in value, best in class. It allows you interoperability so that you can have a hybrid solution. Provides you one standard format for measurement results. It has this persistent traceability across disciplines and then back to the model. It enables quality solutions to communicate inspection results back to the design and manufacturing. We believe it is one of the key contributors that helps quality function impact the overall model-based enterprise. It provides a common format for PMI and features, and it is linked with quality information, and it's a recognized standard. As a vendor perspective, it also reduces cost, and then it also allows you to concentrate on your core competencies. You have this inherent validation that XML gives you to help data correctness. We believe and we understand that the XML schema, there's ease of implementation with that. It's lower cost to implement and use. And therefore, you can minimize your software development. You can also, if your standards based on QIF, you can avoid proprietary system development. The QIF is complete, and it's also extensible. So if you have some uniqueness that you need to extend the QIF for your particular customers, you can do that. And we also believe that the QIF will allow you to expand your market. You'll be able to penetrate other proprietary systems through an interoperability standard. Again, one standard format for measurement results, one common format for PMI and features that is linked to your quality information. Again, it's a recognized standard, both ANSI and very soon ISO. So at this time, we're going to have Ray is going to pop up a poll, and we're going to break up me talking with a quick poll.
So you have a few minutes to fill out the poll. We're going to give you a few seconds here, and if you could take your choice that best fits your organization where you are in QIF maturity, we'd appreciate it. And I'll give you the results in just a few seconds. And I'll give you a moment longer here. If you haven't voted, please vote now. And there is the results. Looks like 40% is investigating. And the next biggest is not doing anything. So this is obviously a good timely presentation for those in those stages. And now I will close the presentation and back to you.
Okay. Well, I think just participating in the webinar, you are investigating, but definitely we do encourage your investigation at the end of the presentation and follow-up emails. You will get opportunities to get to our QIFstandards.org to find out more, be able to download the standard, find out where the QIF community is, and things like that. So thank you, Ray. So I'm going to transition a little bit on how the QIF could be a critical, we believe, a critical enabler for digital transformation. And when I talk about digital transformation, it's going from paper-based, electronic document-based to digital. So some people describe the steps for digital transformation as the following. First step is to digitize or digitalization. It is the process of converting your information into structured data into the digital format. The next step is interoperability, where you want to connect these systems together. And so you can have authoritative sources of data, and then they're connected to other disciplines. And then with that connected data, you have more information that allows you to make smarter decisions, and then even allows you to have tools that should automate some of this decision making for you. And therefore, if you're in the area of product realization, digitalization is via model-based enterprise, and that's model-based enterprise could also be called the digital product realization enterprise. And we believe QIF standard enables this contextual semantic digital interoperability. So it's critical to elevating maybe your definition of your model-based definitions so that quality can participate and not only participate, but impact your model-based enterprise. So let's look at data and information and knowledge and wisdom. Some of you may be familiar with this pyramid, where on the base you have some type of data. It's just raw data. We don't know what the context is, but the minute you put it into some type of context, you have information. And that information, if you apply that information, that becomes knowledge. So in this example, we have data of just some type of number, but in the context of a measurement result for a whole, you have some information, and then with that context, you have knowledge, which is basically this hole size is out of tolerance. The mating pin will not fit into this hole during assembly, and therefore you can apply that knowledge and make some wise decision. We need to remove material so that we can have a hole within tolerance. So we wanted to bring that up to kind of discuss making decisions. You can make decisions just from the raw data. Basically, that requires you to have human in the loop. You have to use your creativity, The process is tedious. It takes significant cognitive load, which gives you opportunity for error. And the solutions may be costly and inconsistent and not repeatable. Where if you can make decisions on structured data or information, now you have opportunities to insert automation or provide that information in the manner that the human can interpret quicker. You can have increased speed in making those decisions, and therefore the costs are reduced. Frees up personnel to perform other tasks more suitable for humans, and you can get repeatable solutions and lower risk solutions as well. So with that information, and we go back to these data, information, knowledge, wisdom pyramid, we acknowledge that there's raw data, but the QIF creates contextual data and allows you to transform this information into knowledge. So the QIF helps provide this context. So kind of in closing, I want to talk a little bit about the roadmaps for successes and DMSC's approach. The DMSC in the area of QIF has active schema development. We have various backgrounds of end users and academia and technology providers and even the government to help us in the schema development. Then using XML and other tools we have data integrity. So XML provides you a schema definition language. It provides you with some capabilities to help you validate your data. Then, of course, the DMSC has standardization efforts. And as being an ANSI accredited organization, we create ANSI standards, and then through our A liaison and the harvesting process, ISO standards can be formed as well. And the QIF through the DMSC are participants with the ISO community. We also are working with other emerging industry standards such as MT Connect, which is very active as well. We facilitate software development. There's QIF code bindings that have been documented and put into our QIF community. You'll definitely see some of that communication going on in QIF 201 and QIF 301. We have some free open source tools. And again, there is a QIF community where we can group together as professionals or as students or anybody that's concerned about the QIF and quality and MBD, and allows you to get involved more easier. Some of the current DMSC members are shown here. We have large companies, small companies, universities, and government. Wanted to show you the current DMSC Board of Directors and officers. We have some good representation of users and providers and academia. As you get more interested in seeking out information on how to join the DMSC, Mark Thomas is our Executive Director. And then many of you may know Bailey Squire, and he's our Executive Director Emeritus. And the Board of Directors has a 3-year stint, and 2 rotate off or gets reelected every 3 years. So my final slide is the request to take action. We'd like for you to spread the word of the QIF. We'd like for you to join the DMSC. And we'd like for you to visit the QIFstandards.org and download the QIF. So with that, we can open it up for any questions that may have been shared.
Curtis, we've had quite a few. I'm also going to just to make sure everybody knows we have some panelists on today that might also be answering. So just we'll put it on the list here. First one I have is I hear there are competing formats in Europe. What is NIST or DMSC doing to harmonize those two standards?
Well, we are aware of a localized specification in the automotive industry over there. We have invited some of their key contributors in the QIF, and actually they have joined a handful of our meetings in the past. They have declared to us that they have no plans of making their spec into national or international standards. We do acknowledge some areas that the QIF does not cover, and they have a spec that we believe could be a de facto standard, and we acknowledge that. And even in our workflow, I did not mention it in our presentation, but we did have a I++ DME section that for controllers. So we believe that with the QIF being an ANSI standard and going in as an ISO, as it's an ISO, there will be other opportunities for people to influence the QIF. And so we always want to make the QIF better. And so if there's other specs or other influencers, we welcome that. And the DMSC in the area of these standards development is required by ANSI to be open so that anybody can participate that has a need.
Okay, the next one is, are the standard formats for QIF plans and results?
Those are two applications of the QIF format.
Right.
They started off at QIF version 1 was just results and plans. But now there is a total of, well, there's 7 application areas.
Okay. The next question is, are there QIF orthogonal captures somewhere for reuse purposes?
Can you broke up? Can you say that one more time?
Are there QIF orthogonal? I'm just saying that poorly.
I don't know what that means.
All right. Let me skip that. I'll go back. Is it possible to add user-defined custom features?
Yes. We do encourage explicit features or explicit entities, but throughout the QIF, and if you open it up, you'll see lots of opportunities for user-defined. Our hope and desire is if user-defined becomes something that needs to be explicit, that it turns into a standard improvement request, so that those needs could become more explicit in the standard, and that obviously will help interoperability if you make it more explicit. But yes, you can extend and customize the QIF for your needs.
The next one is, where can we access the QIF library?
So part of the download includes a group of XSDs that are labeled as library, QIF libraries. And so when you download the standard, you'll see library XSDs or schemas, as well as the application schemas.
Okay, the next question isn't a question, it's a statement. QIF is a thing of beauty. Well done.
Well,
no answer required.
Thank you. We want to meet that person.
We will be looking at the standard later this session. Great. Will we be looking at the standard later in this session? And I think the answer is yeah.
Yeah, our plans for QIF 201 is for Daniel Campbell, and I'll just go into that next slide because that is our next tutorial, is to review more of the data model and some key aspects. So it'll be a good medium review of the data model.
Yes, and by the way, if you haven't signed up, I'll be sending with the email on this one with the link to the video and to the presentation, the link to register for the 201 and the 301 classes. Next question, does the D tie back to the specific serial number and time, date of location?
Say that again, please.
Does the UU or the QPid tie back to the specific serial number and time and date of location?
Yeah, it depends on where you've attached that UUID to. So if you attach that UUID to the QIF document, all the information such as that belongs to the QIF document, you'll be able to trace back to, find that type of data. And so the persistent UUID just gives you a unique ID so that you can reconnect information that has already been captured or new information that needs to be associated with other data. So that's kind of a yes and no.
Yeah.
No, the actual UUID does not have that, but connecting it will get you to that information.
Okay, next question is, does the ISO 23952 include all 7 sections?
It does. They took it all. And I know the ISO community is meeting in May, and I think we're just going through the formality of getting a cover sheet on the. They're essentially taking the ANSI English document and the schema, putting on a different cover sheet, referencing different copyrights, and so that has to get into the proper ISO format, and then they will announce that it's been approved, and then they will publish it at some other date that tells the world that this standard is an ISO standard.
And just to be clear, the 23952 is the QIF, right?
Yes, that's what I'm told. That's the number.
Right. There was a question. Next question was, is this going to also be for optical CMM use?
We think there's some good contribution of optical CMM use. We know that CMM there is resources. The Metrology resources has those types of resources in it, and we would encourage optical community to participate and give us that evaluation, because we attempted to address that community as well.
Okay, next question is, where can we access the QIF plans, quality plans for entering measurement data? And
well, the QIF is a schema, it's a format, and then vendor companies will create actual instances of the data in the QIF format. So you're going to have different software suppliers create QIF plan instances for your particular applications. So the schema documents how you do that, documents the format for exchange, and then vendors will create instances in the QIF format based on that schema for you to do QIF planning or QIF results, things like that. So you need to talk to your favorite vendor and ask them how they're going to support exporting or importing out QIF plans so that you can take advantage of those.
And the next question is really, how long will XML last? The question is around that the person has a 40-year product archiving requirement. and just the longevity of XML as a means of containing the information.
Okay, I did not know it had a 30-year, but you know, 30 years, I'm sure there's going to be other mechanisms for exchanging data, and the QIF will conform to that as well. I mean, we're seeing the other standards out there changing from their old formats to XML or to other SysML or whatever, and so we'll see that transition as well within the QIF in the future.
And we went out of our way to make QIF suitable for long-term archiving. There are several things in QIF explicitly put there to make long-term archiving feasible.
Okay.
Yeah,
and
thank
XML
you.
as an open document standard has been in the industry already, and that's the intention of the XML format. So.
Yeah, it'll be around for a good while, I think.
Okay, just trying to get to the next question. Are there any metrics on the potential savings by moving to QIF use?
I'm not aware of some captured metrics at this point in time. That might be some good questions that we can start asking as more and more vendors are embracing, as more and more users are asking their vendors to start using it. So I think there should be significant, myself, just going to the digitalization process, there are examples of some significant savings, and if the QIF is a major contributor to that, I would say that QIF could claim a big part of that savings as well. But no, I do not have a specific metric at this point in time. If any panelists know, or if anybody know about a study, if they could populate that in the chat window, that'd be great.
Next question is, can you expand on the MT connection and QIF connection?
A little bit. Many of you, if you've gone to the IMTS show, have seen MT Connect being very well connected with a lot of the machining. And then last IMTS show, Martin Hartwick showed some capabilities where MT Connect with STEP with QIF were combined to work together. So I believe the MT Connect is more of, at least what I've seen, is more of a dashboard monitoring some of the activities of the machine, and therefore there is elements of the QIF, not the entire application suite, but they're using the QIF format to also augment what MT Connect is doing in their space. Looks good for us, and so we have memorandums of understanding, and we are furthering our relationship with that group to understand how we can work together and how these two standards can complement each other, and whether the QIF standard needs to be tweaked a little bit, or maybe we can identify a subsection of the QIF that MT Connect needs, and we can kind of document that better.
Great, thank you. The next question is the QIF derivative the single source of truth now, or is it the MBD?
Well, it depends on your discipline. So if your product definition, what's your single authorized source for product definition? It could be what you declare as a business. If you want to capture everything inside QIF plans for the plans, your business can decide QIF plans is your authorized source or format for that. Your source will still be wherever you store that or manage your documents or manage your QIF files. So it's that's I guess that's what I'm going to say on that.
And next question is, what is the current level of support in CAD systems?
Just like if you follow the old days where IGES standard was around and then the STEP standard, typically third parties provide that translation capabilities, and then eventually the individual CAD system, CAD companies would support it themselves. And we'll probably see the same thing here with QIF MBD. And so it's going to take users like you and CAD vendors seeing that the QIF is real, and that people are wanting to start using it and see the advantage of it, and they will start incorporating QIF, exporting and importing and creating tools that could help import and export QIF. And eventually, but we expect to see a lot of third-party vendors providing that capability specifically for the QIF MBD, and we'll see where the business takes people.
So I have one more here because we're running out of time, but it really wasn't a question. It's an answer to, I think, an earlier question from Cullen. He says, we've been testing QIF and suppliers have come back with some very good benefits for time savings and reducing C&Q and less RFIs. So I think that was one of our users that are getting some very positive savings justifications for a QIF. There are more questions.
Thank you for sharing that.
Running out of time. I do want to remind everybody again that we will be sending out the presentation. We will be sending out the link to the video and registration links for the QIF 201 review of QIF technology by Daniel Campbell, which will be a week from today, same time. And then the more detailed, in-depth one, QIF 301 with coding on QIF application by Tom Kramer. For those who want to get into the details, it's an excellent presentation. And again, this will be all sent to you. We thank you very much for your time today, and this was a productive and good learning experience for you. Have a great day, and thank you.
Thank you, everybody.